Hi class, this video is talking about what are recursion functions. We will demonstrate two examples right in the recursion function. We will solve the problem to find the factorial of a number and the Fibonacci number. The first thing, let's go over what is the definition about the recursion function. Recursion function actually is the function that will call itself. Okay, so that will either directly or indirectly. Directly mean in the function implementation, they call itself. Indirectly mean you may have recursion function, they don't call itself, but they call the other function, but the other function call back for this function. So that will be the recursion function. So the recursion function can help us to solve many problems. They have the situation in common. That's the problem always can recursively using the same solution. At the end, we have a complicated problem. We're using the similar approach to make this complicated problem to be simple. So at the end, actually, we have a simplest cases. That's we call that the base cases. That's very important. You have to have at least one base case in your recursion function. Otherwise, your recursion function will never finish. Okay, so let's see our example. The first one actually I want you to talk about is factorial. So everyone understand the definition for factorial, right? So if I say I have n factorial, that means we are looking for 1 times 2 times 3 until times n. So you need to be careful. 1 factorial equal to 1, but 0 factorial is also equal to 1. So that's the definition from math. Of course, you can write this factorial function in a for loop. So here, I want you to pause this video for a little bit. I want you to write a function that's including a loop to find the factorial n. So the function prototype is like this. I pass in a value n, so you will return the n factorial. You can pause this video, so I will write my solution here. Is that your iteration factorial function? Yeah, so you can see here, right, because we have 1 times 2 times 3. So that's why we can have a product equal to 1 stuff on that. So then we can have a for loop to write the iteration function to solve the problem for factorial. But now I want to see here, for example, how can we do that for a recursion function? How can we using a recursion function to solve the problem? So you understand the factorial is n, right? So can we think about n factorial also equal to n times n minus 1 factorial? Makes sense, right? Very good. So that's what we call that recursion function. Recursion function, if we write the function is for the factorial n, you see here, you pass the value n, you find the factorial n. But this value also equivalent to n times. I call factorial function again, but I pass n minus 1. So that's what we call the recursive function. You can have a bigger problem to solve, make that a little simple. So then when we call this function again and again and again, so then we will find out the value for n times n minus 1, then continue, we can times n at the end. Okay, what does that mean? We see here. Okay, so you will see we have the sample for that. But here I want to show you how I can write a recursive function. So if I call this recursive function, return type is int, but I'm using the recursive factorial. So like earlier we said, we pass an integer n. Okay, so then how to implement this function? So to implement this function, you will see like earlier we say, so if you're passing me the n, actually I can just give you the value is what? Is return n times, you see, n minus 1 factorial. Okay, but this one also mean what? This one actually n minus 1 factorial mean I call the recursive function again, but I pass the value is n minus 1. Okay, so then actually pretty much that's our function body. So we just need to return the value. This value actually is n factorial equal to n times I call this recursion factorial function again. So you see here again, so then in order to find this one, I will become n minus 1 times I call recursive function factorial, but I pass n minus 2. Okay, so this one is we call earlier, you need to have base cases. Because n minus 2, n minus 3, eventually n will be what? They will either equal to 1 or n will equal to 0. Okay, so when n equal to 1 or n equal to 0, remember 1 factorial equal to 1. The 0 factorial equal to 1. So that's why here is our recursive function. Okay, so we see again, when n equal to, for example, 5 is not equal to 1 or 0. So that's why we will return 5 times I call recursive function 4. So then when you have 4, you come here, you call the 4, so since n not equal to 4, so I will return 4 times recursive function 4 minus 1, 3. So you call again. So 3 not equal to 1 or 0, so then you will do the return 3 times recursive function. 3 minus 1 is 2. So then again, so n not equal to 1 or 0, so you will do 2 times recursive function 1. Wonderful. So when you come back, 1 equal to 0, so I return 1. So when you return 1 back, earlier is 2 times recursive function 1. So 1 times 2 equal to 2. So then continue like that. So that's what we told you like this. You will start from 5 factorial equal to 5 times 4 factorial, 4 equal to like this. So when they finish, since we have 1 factorial equal to 1, they will return back, and give you the value. Okay, so that's your first recursive function. Okay, so here if you kind of feel a little confused, you can using the test factorial 1, test factorial.cpp file. We have that in the demo file. So you see you run this program, you will see here is earlier we say that's the factorial function. So here earlier we only use the int, right? So here they use unsigned long is because when the n is really big, our n factorial is really big. Okay, so here they only do number equal to 0 for the base cases, but if equal to 1, you can add that too. So this main function actually they just have a for loop to show you factorial start from 0 to n, what is the value, equal to 10, what is the value. Time. So that's why now I will moving forward to the second example for the recursive function for Fibonacci sequence. Fibonacci sequence have the definition is if the Fibonacci 0, the value is 0. 1 start with 1. Any Fibonacci number greater or equal to 2, they equal to the lower 2 number Fibonacci. So for example, Fibonacci 2 will equal to Fibonacci 1 plus Fibonacci 0 will be Fibonacci 1. So this program Yeah, you can think about how to write this function in the for loop to find the Fibonacci number. But here I will show you the first one is we can quickly to use this definition to write the recursion function for Fibonacci. Okay, just like earlier we showed you. If I want to write a Fibonacci function, so this one is for the recursion function. So let me add one more pages. So that's do here is I want you to write a Fibonacci function for the recursion function. Okay. So here, okay. So we call this one is recursive. Okay, I still need to pass the n. Okay, so then here, remember earlier we told you the definition for Fibonacci number is, okay, remember we say if n equal to 1, right? Our Fibonacci n 0, Fibonacci 0 equal to 0. So that's why these two is our base cases. So if n equal to 1, we return 1. If n equal to 0, we return 0. So that's why here we return n. Otherwise, okay, again, we call Fibonacci function. Because remember, Fibonacci number n equal to the Fibonacci number n minus 1 plus Fibonacci n minus 2. Then that's our recursive function for the Fibonacci number. Pretty amazing, pretty easy, right? Okay, so that's here we give you two different examples. This example is using the recursive function to write. That's earlier I showed you the example. So then in the main function, in this test Fibonacci.cpp file, in the main function we will show you for the Fibonacci number start from 0 to 10, what is the value? Okay, so you can run from your site. You see the result. But also you can pause the video now. I want you to see here, you can think about how can I write in the recursion function. So this recursion function actually I didn't include in the PowerPoint file, but we do have that in our demo file. In our demo file, let me see the name. Okay. So the demo file for the name for the Fibonacci iteration, that's Fibonacci iteration function, you can check. Yeah, so that's our recursion function example.